Hello everyone, I'm Jivan Raj, a data science coach at Imaticus Learning. Today I will be helping you to bridge the gap between the SQL and statistics and machine learning. So, for example, consider your data is sitting in the different spreadsheet, or else the data is sitting in the cloud server. For example, you can use SQL as the different tool where you write the information or write a query to extract the information from SQL, and then you take that data and then you process it, and then you do apply the different various statistical techniques, and then you're going to build a machine learning model, that is linear regression. Sounds good, right? So without further ado, we'll start performing the operation. So let me start sharing my screen. So we'll try to deal with the project called Advertisement versus Sales Analysis. Whenever you join any company, the biggest problem is like how much amount if I invest. So what is the Y amount of sales that I'm going to generate? That is the biggest issue. So today I will be here to help you with how to generate the revenue with number of amount that they are investing on the particular product, right? Amount on investment, or else we can also call this as ROAS, return on investment. So, for example, consider this data is sitting in the cloud server, or else the information is sitting in the uh, MySQL. Consider, let me convert this data to CSV format. Let me take it as Excel. So, let me paste it here. So, this is your file. So, I have already downloaded it. If not, I will explain you step by step process. I will save this particular file with CSV format, save as. Let me go to the desktop and then let me save it into Advertisement Sales Analysis .csv. So I will give the extension as .csv file, because SQL do supports only the CSV file. Let me write as CSV format. So now let me go to the SQL server. So let me, for example, consider this is your SQL server where the data is sitting somewhere in the databases. First, let me create a database. So create database advertisement sales analysis DS or DB. So I've created the database. So now I will use this particular database. Let me write as use this particular database. So if you just refresh your schema, can you see here the database is available? Just right click it and then load the particular file. So it is in the documents. Advertisement was sales analysis. Next. So finish. So if you refresh the file, the data is successfully loaded. So this is the file. Advertisement was a sales analysis. Just if you write show tables, so that displays all the tables that are present in the particular database. If you want to load this particular file, you can just write as select star from advertisement sales analysis. If you execute this, so tables will be something different. Let me copy this, copy the field and let me paste it. So let me execute this. So here is the output that is successfully printed. So if you want to download this, you can just click on this export and let me paste this in the document itself, that is sales analysis .csv. So if you want to export it in the different format, you can change the format from Excel spreadsheet. If you click on OK, So the data is now loaded in the spreadsheet. If you go to the documents, you can somewhere find sales analysis. This is your sales analysis data that has been loaded. So let me go here and load it once again, export it once again, export sales analysis. Just replace it. Sales analysis XML file is already exists. You want to replace it? Yes, try to replace that file. Sales analysis data set. Let me click on enter. So we have sales analysis data set here. So this is in the CSV format. So now the same data have been attached here for your understanding. So what is the problem statement here is, so in today's highly competitive market, companies spend significant amount on advertisement to promote their products and to drive the particular sales. However, there is a crucial question that how effective are the advertisement strategies is generating the sales, right? So there is no proper idea like how much it is going to generate, what is the revenue that you are making from the particular advertisement. To ensure the optimal allocation of advertising budget, companies needs to analyze the relationship between the advertisement spent and as well as the sales revenue. So they should have clear understanding of how much amount they are spending on the advertisement and what is the revenue that they are generating from that advertisement. There should be clear idea, right? They should see the correlation, how much it is correlated with each other. For example, tomorrow, if they are coming to us and they are stating that if I invest 100 rupees, what is the amount that I am going to generate from that 100 rupees. So today I will be helping you on this, that is advertisement versus sales analysis. So if the budget is X, what is the sales that is going to generate? So the goal of this analysis is to examine the impact of various advertisement channels on the sales performance by analyzing the historical data and advertisement cents and as well as what is the amount that they are going to generate. So that is nothing but ROI, return on investment of each channels. So here they have provided some details. So as everyone knows that X is nothing but your independent variable and the Y is your dependent variable, where sales is dependent on advertisement, right? So this is the amount they have invested on advertisement, like $92, $93 and $95, and this is the sales that they are going to generate, that is $950, $980 and as well as $1,030, etc. That has been mentioned in below. So now we'll try to break down this step by step. The first thing what you can do, if you want to see the correlation between the advertisement and sales, you can do it. If you want to check the correlation, you can simply write somewhere here, checking the correlation. So I will make this into central alignment. Let me zoom it. Let me keep it into bold. So to check the correlation equals correlation, C-O-R-R-E-L, correlation between the two arrays they are asking. So let me select the first array as your advertisement, control shift down, comma. The next array is your sales. So select the advertisement and sales. So this is telling both advertisement and sales is 97% correlated. That is 97% positively correlated. Correlation between advertisement and sales. So that's good, where it is 97% correlated, that's totally fine. So now, let me increase the size. Let me build the machine learning model. To build the machine learning model, what you can do, you can just go to this different tabs. In the different tabs, you can find somewhere data tab. in the data tab, you can find data analysis. Just click on this data analysis toolpack. So here you have the option called regression. You want to search for regression because you are building a linear regression model. So we can see ANOVA test, descriptive statistics, histogram, etc. Also, you can see there is a regression. Select this regression and click on OK. So it is asking what is your independent variable and what is your dependent variable. What is your y and what is your x. My y is nothing but my sales and my x is nothing but your advertisement. So I will select this y and I will select all the information that is applied for sales analysis. And I will go to the x, that is nothing but your independent variable. I will select all the information of x. So here there is an option whether there is an labels or attached or not. Yes, I have selected the label where I have selected advertisement and sales as it. So click on this, labels is selected. By default, the confidence level is 95%. That's good. So they are asking me whether you want to create your entire report in the new worksheet or existing worksheet. So you can click on output range and you can provide the sheet range somewhere like where you want to perform your linear regression summary report and then click on OK. So here you go. Within 2 to 3 minutes, you are able to create a summary report of linear regression where it provides you what is the correlation, that is 97% correlated. That's what we have checked over here, 97% correlated. And you can see your R squared, adjusted R square, standard error, observation. Totally we have 50 observations and all the informations we have, we can see here intercept and as well as what is the coefficient that are available. So now we'll try to deal with each and every parameters. How did the Excel has been able to calculate all this information? We'll try to break down it step by step process. So first thing what I can do, I can find the correlation between the two different features. One is advertisement and sales. So the correlation between two features between the advertisement and sales is 97%. So let me mark this. This is able to explained. So now I want to see how to perform the R squared and adjusted R square. So R square, to find the R square and adjusted R square, the lot of process needs to be done. So we are using a linear regression, that is nothing but y is equals to mx plus c, right? So y actual is already provided. So we want to write it as y pred. So y pred is equals to mx plus c. That is nothing but y prediction is equals to m stands for slope, c stands for intercept, slope, or also we can call this as coefficient. And your x is your independent variable. So these are the parameters that we already know. So now we'll try to perform a graph to see the correlation between these two variables. So let me select these two graphs, these two columns. I'll go to insert tab. In the insert tab, you can somewhere find the scatter plot. Click on the scatter plot. To check the correlation between the two features, it's always best to use scatter plot. So once you select the scatter plot, the data looks like this. So you can see the data is like having positively correlated. So let me drag it outside here. So, but the data information is not properly visible because all the information is in this particular trend line, right? So let me change my x-axis and y-axis here. So my x-axis should start from 80 and y should start from like 900. So how I can do this? I can just double tap this. Once you double tap, you can find this format axis. In this format axis, the minimum is 0. I'll change this minimum from 0 to 900. So it is starting from 900. So I will change the same thing for the x-axis. So I will change that 0 to 80. Or 90 for better understanding, right? So it is starting from 90 and this is starting from 900. So let me make this as 850. So you can see here the data is like positively correlated. Let me also add the straight line on top of this. So I will go for the trend line. So can you see here, this is your trend line. If you want to change the color of this trend line, you can do it. Just select this trend line and change the color of this particular trend line. So this is your predicted point and this is your actual, the point that displays the actual points, and this is your trend line, that is predicted line. So we'll try to do this entire operations by using Excel. So first thing, to find the slope and intercept, where I've also defined the formula I mentioned here. First you want to provide the SSR. To find the SSR, sum of squared residual, sum of squared error and sum of squared total, you first want the slope and intercept. So to provide the slope and intercept, first you want to find the regression coefficient. So let me write as regression coefficient, that is nothing but your B1. It is represented as B1 regression coefficient. So let me copy this regression coefficient and change the color to blue. Let me make it as bold. Let me increase this size. So the formula for regression coefficient is sum of squared xy divided by sum of squared xx. So what is the sum of squared xx and sum of squared yy? Alright, this is your question. This is your B1. To find the B1, you want to perform this sum of squared xx and as well as sum of squared xy. So when you take this particular line, let me draw a simple line or I've attached the image here. So this image will help you to understand what is your sum of squared residual, sum of squared total and then sum of actual. So this y bar that is representing in the green line is nothing but y bar, average of y, and this blue color line indicates the y predicted value and this is the y actual point. So from y actual to y predicted value, y predicted value we call it as sum of squared error, SSE, that is nothing but actual y and the predicted value of y, that is sum of squared error. Sum of squared residuals means from the predicted value to the average value, that is nothing but from the y pred to y actual, y average or y mean you can consider, or y at you can consider, anything is fine. You can y bar, you can write this. So next you can see here sum of squared total. The sum of squared total is calculated based on the actual data point to the average bar, that is nothing but y actual minus y bar. So this is your SST, sum of squared total and sum of squared residuals. So this is how it is calculated. So to find sum of squared xy and sum of squared xx, what I can do, you can create a new column here. Let me represent the new column as sum of x and sum of y. First let me go here and find the total x values, that is nothing but alt equals, and this is your sum of values and then your sum of y, that is nothing but here let me write alt equals. So you will get the sum of x and as well as sum of y. So sum of squared x and y I want, so I will provide x into y. So this is what your x multiplied by y. That is nothing but this equals to 92 multiplied by 950. Click on enter. So you'll get some value. Apply it. So alt equals. So what is this? This is your sum of squared xy. And I also want to provide xx to perform the xx, x into x is equals to this multiplied by the same element. So now you will get the value of sum of squared xx. So the output of sum of squared xx is nothing but, where let me write it as alt equals. So I will get the output of it. So now I got sum of squared xx and as well as sum of squared xy. So now I will perform some operation is equals to find the sum of squared xx. I want to first make sure that SS xy and XS xx. So to calculate SS xy, sum of squared dependent and independent variable, you can just write it as sum of squared dependent and independent variable, dependent on dependent features. So you are providing sum of squared dependent on independent features. Then sum of squared dependent, sum of squared independent and dependent features. So to perform the sum of squared independent and dependent features, what you can do, you can just let me make it into yellow color. So to do that, what I can do, to calculate this sum of squared independent and dependent features, that is sum of xy, sum of xy minus, let me add the values. So that is already I have maintained a script file here. Let me copy this. Let me paste it here. So this is used to provide the sum of squared xy and as well as sum of squared xx. So this is your sum of squared independent and dependent features and sum of squared dependent features. So let me add this as sum of squared dependent variable or dependent features. Let me copy this and paste it somewhere here. So sum of squared dependent features. So to do that, what I can do, I will go here equals to sum of x into y. This is your x into y and the sum of this is this value, that is D77 minus, I want to perform sum of x. What is your sum of x? That is nothing but 6551 into sum of phi. What is your sum of phi? That is thus 75,799. So let me create another bracket here and let me close this bracket, whole divided by number of observation. To find the number of observation, I am using count of this entire observation, right? So let me select this entire value. So click on enter. So you'll get this values as 37,000, 3,76,843. So this is your sum of squared of independent and dependent features. So let me make this as xy. So sum of squared independent and dependent features. So let me give it into green color. Let me put it into bold and then let me increase the value size. So let me give it into brackets. So this is your sum of squared independent and dependent features. Now let me perform sum of squared for dependent features. So to find the sum of squared for dependent features, that is sum of x square equals sum of x square. So we have already created x square here, x into x. So this is your sum of x squared minus sum of x whole square. This is your sum of x. So I want to square that to the power of 2 whole divided by number of element, that is nothing but number of observation. Let me write as count of all the elements, that is from this to this. So click on enter. So the output that you are getting is 28,000. So that is your sum of squared dependent features. Let me write as SSXX. So you got the output of SSXX and as well as SSXY, sum of squared dependent variable and then sum of squared independent and dependent variable. So that's good. So once you found the sum of squared dependent and independent variable, you want to find the regression coefficient. So let me add this regression coefficient below this. So the first thing, you want to find the correlation matrix. Once you have done with the correlation matrix, you want to find the sum of squared dependent and independent variable. Once you are done with that, you want to start performing the regression coefficient. So let me take this, let me mark it here. Let me take this and let me mark it here. So this looks good. So next thing, what I want to do, I want to perform for regression coefficient. To perform the regression coefficient, let me copy paste the formula for your better understanding. Let me copy it and save it here. So this is for regression coefficient and this is for intercept. So to perform regression coefficient, that is sum of squared xy divided by sum of squared xx. Where you have performed sum of squared xy and as well as sum of squared xx, you can just perform the operation, that is nothing but b1 is equals to sum of squared xx, that is nothing but this parameter, divided by sum of squared xy, this is the parameter. Sorry, equals to sum of squared xy divided by sum of squared xx. So I will get the output as 13. So what is your regression coefficient? That is 13. What does regression coefficient means? So your regression coefficient helps you to understand, for 1 unit change in my x-axis, what is the unit change that happens in the y-axis? That is what your regression coefficient explains. For example, for the 1 unit change in my sales, 13, for 1 unit change in my advertisement, 13.42 sales will get generated. Okay. So now we'll talk about the intercept. So let me write as what is regression coefficient. For 1 unit change in my x-axis, what is the unit change in my y-axis? So this is what your regression coefficient explains. So now we'll talk about the intercept. So let me copy this same and let me paste it here. Let me make it this as intercept. intercept, let me make this intercept as BO. So how do we calculate BO? That is nothing but sum of y is equals to sum of y. So where is sum of y? This is your sales. So sum of sales divided by total number of observation, that is nothing but count of n, that is nothing but your all the observation details, control shift down. So I have selected all the observation details. So give it into bracket. So this is your first argument, that is sum of y divided by n minus b1 is nothing but your slope details, regression coefficient, multiplied by sum of x divided by n. Sum of x is what? This is your x value. Sum of x is 6551 divided by total number of observation. Count of again all the observation. So let me select this. And click on enter. So I got the output of intercept. So what does intercept indicates? So my intercept is now minus 243. So what this indicates, let me explain you. Before that, let me copy this and format this for this data. So note, your intercept explains if there is no unit change in my, for example, if there is zero amount invested in the advertisement, what is the sales that is going to generate it? Okay, that is what your intercept is. When your x is 0, what is the value of y? That is what intercept explains. The line where the point cuts the y-axis is intercept. Okay, that means when the axis of x, when the value of x is 0, what is the value of y? That means when the value of x is equals to 0, then what is the value of y? That is intercept. So this is what intercept is all about. When the value of x is 0, what is the value of y? So I hope everyone understood what is your slope and as well as intercept and how to calculate it. So this same thing is also replicated in the particular summary report that Python, that is Excel generated. Can you see here? So this is your coefficient and this is your intercept. Coefficient is 13.42. So the same thing is present here, that is 13.42 coefficient, and the intercept also mentioned here, that is minus 243. So let me mark down this both the color as green. So we are able to calculate this as well. We are able to calculate the coefficient, the correlation between the advertisement and sales, and we got to know the total number of observation is 50. So once you have done with that, let me go and calculate the predicted values. There is nothing but actual and predicted value, that is regression coefficient. Applying an regression coefficient. Let me copy this and paste it somewhere here. Let me write as regression equation. So regression equation is nothing but, let me make it merge and center. So regression equation is y is equals to mx plus c. So what is your mx plus c here? So this information can be written in different ways. Rather than mx plus c, we can also state that y is equals to a plus bx, or else you can also say that y is equals to bo, that is nothing but slope, plus bi, that is intercept, into xi. Okay, yam is nothing but your slope, x is the independent variable and c is intercept. So here a plus bx. So a is your intercept, b is your slope, and x is your independent variable. So bo is your intercept and bi is your slope and xi is your independent variable. So let me write it down here. Note, y is your independent variable, y your dependent variable, dependent features or dependent variable, and your m is your slope and c is your intercept. So the same thing, let me drag this down. So y is your dependent variable, rather than m we have specified it as b, and let me specify here, instead of c they have written it as e. And here let me make this slope as bi, and this is your intercept bo. Okay, bo is your intercept and bi is your slope. So that's good. Now we'll implement the regression equation for the particular problem statement. Now we'll try to implement the regression equation for the given problem statement. Now we'll try to implement regression equation for the given problem statement. So let me select this. Let me merge and center. Let me give it into a green color. So let me increase the size of this. Okay. So for an example, if to find the regression coefficient, let me specify here y equals y is equals to mx plus c. So your y pred value is nothing but y pred. You know what is m, you know what is x, and you know what is c. For example, they're asking you, consider if the budget that they are investing is $95. So what will be the sales that is going to generate, right? So at the rate of 95 as the budget, so if they provide the budget as $95, so what is the sales that is going to generate? What is the sales? So to find that, I can simply write as m, I already know, that is your slope regression coefficient, m into x, x is nothing but your 95 plus c, c is what? C is your intercept. So I'll get the details of 1032.32. So is it the right value? Yes, it is the right value, but not the right way of explaining to the stakeholders. Why this is not the right way of explaining to the stakeholders? In the sense, this is the point estimated value, whereas our data also adds some error. Can you see here? This is the estimated value that we got, but the data also have some error, some positive error and as well as some negative error. So where is this errors are going? Always while explaining to the stakeholders, you also want to include your error and then you want to explain it. To do that, we can first find the standard error residuals and then we can start predicting it. Rather than directly predicting it, we want to first use the standard error residuals. To perform the standard error residuals, let me go and copy the procedure to find the standard error residuals. Let me copy and paste it here. So here is the standard error residuals formula. That is nothing but summation square root of sum of squared error divided by n minus k minus 1. N indicates the number of observation, k indicates the number of independent features, and minus 1. So is equals to, you have not created what is SSC, sum of squared error. I have already defined it for SSE, SSR and as well as for SST, how it is going to calculate. Based on this particular graph, you are able to come up with this equation. So now let me find the SSE. Before finding SSE, I also want to have the Y predicted value. To have the Y predicted value, let me write it as Y pred. So how to find the Y predicted value? That is nothing but your MS plus C. M is what? M is your slope. This is your M. Let me freeze this particular cell. M into X. X is what? Your advertisement. X plus C. C is your intercept again. So select this intercept and then freeze it. If you execute this, now you will get the Y predicted value. So the actual is 950, but the model is predicted as 992. The actual sales that was generated is 980 and the predicted is 1005 and the actual sales is 1030. For the advertisement is $95. So what is the model is predicting? The model is predicted as 1032. So that's good. The model is able to predict almost properly. So equals to, so this value is nothing but your Y predicted value, sum of Y predicted value. Okay. Now we'll try to perform SSE, sum of squared errors. So let me do some coloring format here. Let me go and add some color. Let me also increase this value. So let me change the text value from red to white and let me give it as middle alignment. So that's great. This we have done till here. So to find the SSC, sum of squared error, that is nothing but Y actual minus Y predicted value. So where is your Y actual value? Equals to, this is your Y actual value minus this is your Y predicted value. So now we will get the sum of squared errors. So here the sum of squared error, it is printing it as minus 42. Let me drag it down. So this is your sum of squared error. Just let me write alt equals. So next we'll try to perform for sum of squared residuals. So to find the sum of squared residuals, you want to write it as Y predicted minus Y bar. So there is no average Y here. So to find the average Y, let me explain you. So is equals to Y predicted is nothing but this is your Y predicted value minus Y bar, that is nothing but mean of average of Y bar, that is nothing but this Y. I will use function here for, I will freeze it. So this is your SSR, sum of squared residuals. So now we got the sum of squared residuals as well as the output. So always make sure while performing this operation, you are also using the proper appropriate information, that is actual minus predicted whole square. You want to square these values because there is a chances that positive and negative error, right? You can see here there is a chances of positive error and as well as negative error. The model should treat both positive error and negative error as different. So on top of this, you want to perform the squares to the power of 2. Same thing I want to do for sum of squared residuals as well. On top of this to the power of 2 and as well as I will do the same thing for this operations as well to the power of 2. So now I want to slightly change with this formula of sum of squared error to the power of 2. So let me apply this same for all the records. So my sum remains the same. I will do the same thing for sum of squared residuals. So this is your value to the power of 2. So now you get the value of sum of squared residuals, that is nothing but sum of squared value is calculated based on the y predicted minus y bar whole square. So what is your y predicted y bar value equals to average of all the observation of phi. So your y bar value is this one, y bar. So let me copy this, or let me format this particular data. Let me select and let me format these values. Let me make it as bold and let me keep it as central alignment, right? So sum of squared residuals are nothing but your y predicted value minus y bar whole square. So you get the y predicted value equals to, this is your y predicted value minus y bar, that is nothing but this is your y bar. Let me phrase this to the power of 2. So this is your SSR, that is nothing but sum of squared residuals. So let me apply the same thing for all the observation. So let me use alt equals to perform the sum of all it. So finally we'll try to solve the SST, sum of squared total. To find the sum of squared total, that is nothing but your actual value minus y bar whole square. So let me copy this. Let me also place it here. So that is nothing but y actual is equals to, where is your y actual? Your y actual is this minus y bar is nothing but this amount function f4. So to the power of 2, let me close this. Let me write as to the power of 2. So now we got the output of sum of squared total. Let me add it for all the observation. So alt equals. So this is your final output. So now we are able to print the sum of squared residual, sum of squared error, and as well as sum of squared total. Let me copy this and let me give some coloring. Let me go and give the light coloring for it. So I will also use this perfect alignment. So now we are able to get all the details. So now it's simple to find the sum of standard error residuals. So to find the standard error residuals is nothing but equals to square root of sum of squared error, that is nothing but the error is this sum of squared error all divided by n minus k minus 1. N is nothing but count of number of observation, count the number of observation, that is this, comma, your k value is nothing but number of independent variable. We have only one independent variable, that is minus 1 and 1 you are providing. So close this bracket and click on enter. So you get the output as 67.15. So what is this 67.15 is the question. So how did we calculate this 67.15? So now we'll try to do the further analysis. What is the help of this 67.515 etc. We'll try to discuss. So let me add it somewhere here. Standard error residuals, SER. So let me make the coloring for this particular data for SER. Let me give the bold format and then increase the size of this. Let me also provide the alignment. So this is totally done. So what is the help of SER, sum of standard error residuals, and how to predict the practical, how to use this in the practical implementation? Let me explain it, right? So what is the practical use of standard error residuals of by using 67.15? So now let me go and perform the same thing for 92% of the confidence level. So we got some value. So I'm using this central upper limit and as well as lower limit of sales. To find the upper limit and lower limit sales, you can just copy this details. Let me copy this as well, the entire information. And let me go back and let me paste it here somewhere. Okay. So now it's never the good practice to directly mention this sales that was generated as 1032. So always it's better to use upper limit and as well as lower limit while expressing the sales values. So this is we call it as point estimated values. To explain with terms of upper limit and as well as lower limit values, you can use upper limit values or upper limit sales, that is nothing but y predicted plus critical value of z at 95% of the confidence interval at 95% of confidence level multiplied by standard error residuals. This way we can find the upper limit of sales, and to perform the lower limit sales you can do the same thing, but only difference that happens in the upper limit sales and as well as for the lower limit sales, where rather than writing a plus you will write as minus, that's it. So let me copy this and let me paste it as lower limit sales. Lower limit sales. So to find the lower limit sales, instead of positive you want to make it as negative. To find the upper limit sales and as well as lower limit sales, let me make it into bold format. Let me increase the size of this, and as well as let me do the same thing for this as well. So we don't know what is the critical value of Z at 95% of confidence level, but we know the standard error residuals and as well as Y predicted value we have already defined. So now to find the Z value of critical value of Z at 95% of confidence level, what you can do, as we see the entire distribution is 100%. In this entire distribution, we call that as 1, that is nothing but 100% because this is a bell-shaped curve. In this bell-shaped curve, let me take it as just 50% of the portion because I am looking into the table, T table or the Z table, which is in the right or left table, right? So I am taking this only 50% of the information, that is 0.5 minus, so this is your critical region, that is nothing but alpha by 2, that is nothing but 0.05, entire distribution of 95% of confidence interval. If the confidence interval is if the confidence interval is 95%, if the confidence interval is 95%, then the critical region is nothing but 5%. 5% of the error rate, right? 5%. So if it is 95%, the 5%. So 5% is nothing but if it is divided into two different halves, that is 2.5% and 2.5%. That is nothing but 0.025 minus 0.025. This is how it is calculated. So you can write equals. So I want to find the critical level for 0.475 in the T table or the Z table. So you can go to the Google, you can just search for the T table or Z table. So you'll get this particular chart. So based on this particular chart, you can just start making an analysis. So let me take it as right table. Any table is fine. Let me see in this Z table. For what is the value? For the value of 0.475. For the 0.475. So there is no 0.475. Let me take down the another table. So here also there is no 0.475. Let me select this. I have already calculated. Let me copy the same thing for 0.475. You can print somewhere here. So this is the table. So this is the 0.475 value. So this value indicates a 1.9 on the left side. On the top, it is 0.06. That means 1.96 from the Z table. So for the 0.475, the value that we are getting is 1.96. So from this 1.96, how we can calculate the remaining stuff is where, let me mark this into bold color and let me give it into green. So this 1.96 is nothing but the critical value of Z at 95% of confidence interval. So that is nothing but critical value of Z at 95% of confidence level. So let me mark this. So now let me calculate the upper limit sales and as well as lower limit sales. So lower limit sales is nothing but L as lower limit sales, or else let me paste the same thing. So that is nothing but equals to Y predicted value. What is the predicted value of Y for the 95% of the sales? That is this one minus critical value for the level of 95% confidence interval. It is this multiplied by SCR. That is nothing but standard error residuals. That is 67 point something. So the output that you got is 900.896. So that is from lower limit value. So the upper limit, if you want to calculate the same, you can just print below. So critical value for the upper limit sales, that is Y predicted value. This is your Y predicted value plus critical level, that is 1.96 multiplied by standard error residuals. So SCR is nothing but 67. So if you click on enter, so you'll get the lower limit of sales and as well as upper limit of the sales. So this is your lower limit and upper limit of the sales. Let me format it and let me paste it here. So this is the output that you got. So once you get the lower limit sales and as well as upper limit sales, so now you are good to go to explain what is the overall sales that is going to generate. So always it's best to explain to the stakeholders in such a way that the sales for the budget of 95 will be generating between 900 to 1163 rupees. So you will say that you are 95% confident. You are not telling 100% confidence, you are just stating you are 95% confident that the sales corresponds to $95 of budget of advertisement will lie between 900.69 to 1163.94. So this is better way of explaining to the stakeholders rather than explaining in the above term. So instead of directly telling the point estimated values, like this is your point estimated value that we have created, that is the approximate sales will be generated between 1032. But we also have some error, right? The positive and negative error. So by considering those positive and negative error, you are going to state that this is the sales that is going to generate. Well, let me color this information. So we can easily say that for the 95% of the confidence interval, the sales will be generated for 95% of the budget ranging between 969 to $1163. So that's how you can easily calculate the predicted values for the various budget that they have given. So if you also want to do further analysis like based on different statistical tests, you can do it here. So the first thing is, well, let me go here and let me write it down. Different analysis. So the first thing is, we can also see the statistical analysis. So to perform the statistical analysis, we want to mention that your T is nothing but now let me define hypothesis testing here. What is hypothesis testing? As you know, hypothesis testing is nothing but it is a mutual exclusive statement on the population based on sample. What is mutual exclusive statement? A mutual exclusive statement is nothing but both the event cannot occur on the same time, right? That is what mutual exclusive. For an example, if you toss a coin, both add and fail cannot occur on the same time. If you give an example, both rejection and selection cannot happen in the same time, right? That is what mutual exclusive statement. So both the event cannot occur on the same time, either any one event will occur. So now, what is null hypothesis and alternative hypothesis in terms of this problem statement? Let me define. So your null hypothesis states that is HO states that, or null hypothesis states there is no linear relationship, there is no linear relationship between the data, whereas HA, that is alternative hypothesis, state that, or H1 states that alternative hypothesis. So this states that there is a linear relationship, there is a linear relationship between the data. So this is your null hypothesis and alternative hypothesis. Based on the null hypothesis and alternative hypothesis, you are going to interpret the coefficient. So let me copy this and paste it somewhere here. So now firstly let me perform standard error. standard error of regression equation or regression coefficient, that is nothing but your SB. So to find the standard error of regression coefficient, so firstly I want the standard error residual, that is SCR, we already found it out. So divided by square root of sum of squared xx. So we have this information. So let me write equals to standard error residuals, that is SCR, divided by square root of SQRT square root of sum of squared xx. So sum of squared xx is nothing but this one, sum of squared dependent features. So if you click on xx, you can find the what is this standard error regression coefficient. So let me make this into bold and let me color this as well. So now we are able to find the standard error regression coefficient. So now we'll try to find the what is T or test statistics. So to find this test statistics, that is nothing but that is T. So that equals to B1. So let me select your coefficient minus 0 whole divided by what? Whole divided by SP, that is nothing but standard error regression coefficient. So you will get the output as 33.48. So this is the value that you got. So that is your test statistics. So you can find this test statistics in the formula as well. Here also you get the same thing as test statistics. You can just extend this information. So here you got the lower and as well as your upper end values. So that's what I mentioned. So your SSP, SST, SSR will be also displayed here. So that what it is present here, SST, SSR. So what is your sum of squared residuals? The sum of squared residuals is 5,60,000, that is nothing but that is present here, SSC, SSR, SST. So standard error is 54, that is what here we have mentioned, standard error. And the test statistics is available. So based on this, let me mark it in the green color, let me make it into bold format. So now let me find the R squared value. So let me go and print the R squared, copy this and let me paste. What is R squared? R squared is nothing but coefficient of determinants that explains how the independent variable, how much percent of the variance is explained by the independent variable to the dependent variable. That is what the power of R squared. So we have SSR and as well as SST to get the R squared value. R squared is nothing but equals to sum of squared residuals. So sum of squared residuals is available here. This is your sum of squared residuals divided by sum of squared total, that is this. So if you see, we get the output as 95.73%. That means 95% of the variance was explained by the advertisement to the overall sales. So let me zoom this, or let me increase the size of this particular value. So this is your R squared value. Where do I get this? 95.73 is also present in the summary report. 95.73. Can you see here? Your R squared value is already mentioned here. So now we'll find the adjusted R square. So this is your standard error. Standard error is already we have calculated. Now we can find the adjusted R square. So let me paste the adjusted R square. So that is nothing but equals 1 minus, you want to perform the standard error residuals, that is nothing but SSE, sum of squared error, this is your SSE, divided by n minus k minus 1. What is your n value? N value is nothing but number of observations, count of all the observations, that is nothing but from this to all the observation, n minus k is nothing but number of independent variable, that is 1 minus 1. So, let me close the bracket. Let me also close another bracket and let me open here the another bracket, divided by SST, that is nothing but sum of squared total, divided by n minus 1, that is nothing but this is your SST divided by n minus 1. What is your n? That is nothing but the number of observation, count of observation, that is all the observations, minus 1. So, if you click on enter, you will get the adjusted R square value. So, the adjusted R square, it is 95.64. So, let me drag this here, let me write as adjusted R square. So, this is your adjusted R square. So, let me increase this size of this. So, this adjusted R square is already present in the summary report. What we got? We got adjusted R square as 95.64. The same 95.64 is also printed in the summary report, that is 95.64. So, this is your standard error residuals, SER. So, these are the parameters we already found it. So, this is how you can also print the entire functionalities of linear regression and by using the statistical terms, by using the sum of squared error, sum of squared residuals, and as well as sum of squared totals. I hope everyone understood how to perform the simple linear regression by using the various different techniques like slope, intercept, and then we started building your y is equals to mx plus c, that is your regression equation. And then we also tried to understood what is standard error residuals, and also we started performing lower limit and as well as upper limit. So, these are the statistical terms that you can apply, you are going to apply in terms of machine learning. And then you also understood what is standard error residuals and how to implement it, then what is R squared and as well as what is adjusted R square. Thank you everyone.